Now the stage is yours.
Hello, good afternoon. Welcome to the last CRID webinar for this semester. Today we have a special guest, Dr. Satendra Kumar, who is a renowned international forensic structural investigator and crime scene expert using 3D technologies with a doctorate in the field of forensic investigation. His experiences with reality capture for more than 8 years, and he has trained more than 50 various international law enforcement and private organizations working in the field of engineering, structural analysis, and digitalization of assets. He is using BIM and 3D scanning together to solve most complex mysteries from heritage and architectural milestones. I would like to remind the audience, if you have any questions, please type your question in the Q&A section. I'll be directing these questions to the guest, to Dr. Satendra at the end of this talk. It's a special talk, I believe, and we're all looking forward to Dr. Satendra. So that's all from my side for now, Doctor. The stage is yours. Please go ahead.
Thank you, Professor, for giving me this opportunity, and to CRID for organizing such events where we can interact with the people from the field as well as the students over the area, where we can discuss how the technologies are getting implemented and how your existing solutions which you are using in your construction as well as for maintaining the heritage and refurbishing the buildings, how this helps in meeting the current scenarios in the requirements, especially when we have like situations like COVID. So we'll have a discussion on today what reality capture is, how this helps you out in correlating and collaborating with various teams together, and what are the various technical aspects behind this. So I would like to share my screen from here, and then we can have a presentation parallel to that. Okay. Since we know that cities are growing and our requirements for the infrastructure are increasing every day. So in terms when our requirements are increasing, we have to make more construction. Our construction has to be very sustainable. This construction has to have most of the energy conservation parameters in place so that we can have our habitation, we can have our increase in population, and we can accommodate more people in the cities without disturbing the actual nature, which is already in the depletion way. So our construction and architecture has to be more robust, as well as to meet the increasing demands. We have to be always on time so that we can deliver the projects on time, and the construction the things are getting complex day by day. So today I will be discussing more about how reality capture and public safety things are helping to meet the requirements of current structures. So I work in Leica Geosystems as a segment manager for reality capture and public safety. So Leica Geosystems is a Swiss organization with a history of more than 200 years on this year, and we are into constructing and as well as we are into measurement technologies, starting from total stations, those are required for your day-to-day analysis for the construction, till the airborne sensors, those are required for now for smart cities to have the whole connected cities all together. So during this 1 hour or 45 minutes which we'll be discussing now, we'll be learning about what reality capture is. We'll discuss how this reality capture allows you to have more of new career opportunities in terms of construction business, as well as how they can club together. You'll hear few of real world examples. So the buildings, those are around you, how they are getting done and where the reality capture is getting into these things. And then later on, if you have any questions, so I'll be happy to answer the questions. So you can have all the questions, those are coming into your mind, and you can just type them on the chat panel, or at the end when professor will open the session for the question and answer, you can ask your questions directly there. In construction, when we talk about as being all the engineering students and even the investigators all together, when we talk about managing something, there is a saying by Professor Peter Drucker that you can't manage which you can't measure. So basically anything happening on the structure, starting from a land preparation, when somebody says you as an engineer that I want to construct a building on this piece of land, the structure of that piece of land, how you have to go for cut and fill analysis, how the building will look like when it will be erected on that particular space. So you need to have measurements of everything. If you cannot measure, definitely you cannot manage that particular thing. So for that, we have to be very accurate all time. And for that, there are two ways of doing this. One is go with the conventional way, and another way is go with the 3D scanning or a reality capture view, where we can capture everything what is happening around. There are places where you have open lands where you can start construction from zero, and we have lots of room where we want to construct. So we have open area, we have surroundings, those are free for our high-rise cranes, for our structures. But there are positions where you have, most of the cities are already constructed, and we are in an urban environment where we have space constraint. We have to build new environments where the
I'm sorry,
surroundings are.
Doctor, I have to stop you for a second because there is a black gray box on the presentation, right and on top. I have no clue why this exists, and it is actually covering a piece of the presentation. I'm sorry to stop
Okay,
you, but in order for us to see a better, yes, and there's one on top as
so
well.
here.
Yeah.
No, this is the zoom settings actually. So this is zoom setting
Okay.
for.
So on top is
this,
fine, it's very thin, but the one on the right, it was really covering part of the presentation.
yeah,
Go
because,
ahead, please continue.
okay.
Now it's solved. Thank you.
Okay. So when we talk about growing things in construction market, because when you as an engineering student, everybody after your graduation, you are looking for a career, and your career is where the growth talks about. So when you want to move ahead, what is driving this growth? Why people are getting more into construction, where the technology is growing, why we want to use more of the technology? And when today we are talking about reality capture, why we want to use this, why the requirement of this kind of technologies is growing is the key, because that directly links up with various things, like we want to speed up the process. So the building which was taking 10 years, if you go in our heritage and architectural buildings, when we talk about old monuments, when we talk about forts, we always read in the history that this fort took 10 years to build, this another one took 20 years to the build. Do we have that much time that we plan a building today and we can wait for 10 years or 20 years? No, we have to make it fast so that we can cater the requirements as earliest as possible. Second thing is cost, because inflation is always there. What you will spend today to construct a 5-floor building, tomorrow you have to construct, pay little more on that, and year on year inflation keeps on coming. And because of COVID and all this kind of now pandemic situations, if it arises, the project delivery gets delayed and you will end up spending more money. And as an engineer, as an architecture student, when you do budgeting before even the construction starts, those costs have to meet. Otherwise we have to have additional costs included in that project, and that will not be a perfect project planning, and we might have to stop few of the projects because of the cost. So to control the cost, we have to control the time. And when we are talking about speed, delivering these things on time, when we are talking about reducing the cost and optimizing the cost, what is required in terms of calculating the right raw material, in terms of calculating the right verticality, like right flatness of the floors. Even when we are doing the phased construction, we want to make sure that on every stage, every phase of the construction, we are accurate and we deliver the quality so that the building should sustain for years together. And in terms to meet all these three requirements, we have implemented a new, we can say, era of building information modeling, which was started 10 years back, and slowly we became LD 100, 200, 300, 400, and now we have started even implementing the sensors related to the environment so that we can have more about the building information. Building information was more about maintaining the project, monitoring the solutions, and even monitoring the progress monitoring of construction so that all the project always remains on time. The building plans are recent and updated, and we are aware about every know-how of the building. But that was not enough, because we wanted to know where exactly my building looks like, where it lies in the area where I have surroundings. And then the new concept got involved, which is called GIS, basically. That was Geographical Information System as well. We have added to the BIM. And now together, now we have smart city concept, where we can have whole the city. We know each and every building, where exactly those are in the geolocations, how they are communicating with each other, how we can have less traffic congestion on roads, how we can have more occupancy on the buildings, how we can have smart buildings where we can monitor the energy consumption, where we can have the refurbishments, we have replannings of the buildings. So this all together came in picture, and we had a smart city concept as well. But the problem during meeting all these analysis, like I plan a very good building on my laptop, and a construction guy who is actually doing on the road, who is doing a construction, delivering this change, what is in my mind, what is in my laptop, to the field guy was always tough. And what is coming from the field has no relevance with our data. So there was always a discrepancy between what is happening on the ground and what is in the office. And we used to realize these differences when the building is ready for the use. And it was, for example, if I should take you, there were cases where one guy who is working on the MEP, the piping design of the building, was working and designing all the pipes. Those were required for the construction, but during the construction phase, the contractor found some issue with a pillar, and he shifted that pillar by a feet. Now, to meet all those requirements, he has done a very good construction, but this small change of a movement of pillar was never communicated to the guy who was doing MEP, and he had a construction collapse where his pipe will hit the pillar and then he will not be able to take that particular thing. He has to roll it around, which he was not prepared for. So in all the construction phases where we go and optimize those changes, these changes keep on changing, and then when we go for final stage, we find, oh, there are too many flaws on the building now, and how to deal with that. And sometimes we have to go for reconstruction, and there is a saying that around 7% of the cost goes in removing the errors which we are facing day to day. So most of the construction companies, those are working in the field of engineering, in the field of architecture, as well as those are into refurbishment and heritage restoration, spend around 8 to 10% of their total profits just in correcting those mistakes. Why these mistakes happen? So these mistakes happen because of the wrong measurements, wrong update of the information, and have a timely information about any changes which we design. And for that, currently there are two things which people do. One, there are people those go with these kind of scales where you see a picture on your right side. So the people those have this mindset, they go with a scale and they try to measure the things. There are few places where you cannot jump on and then you can't have measurements, so they use normal digital meters where they can take the measurements, but they are not always correct. There is always a tolerance and a issue with the understanding of human accuracy. So human error has always been there, and this might lead. And now, since we all are now looking at Zoom, sitting from at a comfort of our homes, just imagine if you have to go out and do this job for a building in COVID times. You will not definitely not be able to do, or you will not be happy to do all these things. So in case when we really want to have a right information without the risk of going around the scene, exposing ourselves, we can always ask people those are actually using reality capture or digital 3D scanners. Those can be BLKs, RTCs, or PC read scanners, so that one guy who is already there in the field can scan everything and send this data to you here in your office. And at a comfort of your office, you can visualize everything. You can see things in 3D. You can measure them. And now with these new series of BLK, which you see on your right side, the small 3D scanner, these scanners not only do measurements, but they started capturing the thermal signatures as well. So if you are working for a refurbishment project where you have projects like refurbishment of HVAC plants, heating and cooling systems, so in that case where your heat is there, where you are losing the cold air and there are blocks in between, you can all testing can be done using this LiDAR sensors where you have thermal sensors inbuilt in the devices. So we will discuss all these things down the line, that how these things gets captured. So to capture the reality in 3D, everything what is in front of us, if you want to capture that, we have to have multiple devices together, because there are different devices, those have different capabilities and different uses. As on today, when we talk about reality capture, we can use three different type of devices. One is called TLS, the terrestrial laser scanners, the devices which looks like a left side of your screen, so which is called RTC 360 in the image. So these are terrestrial laser scanners where you put the scanner and then they have a pulsed laser where they keep on throwing the laser on the ground, and then they understand that how much time this laser goes, strikes, and comes back and calculate the distance. Another are mobile mappers where you wear them and you walk around the area and the sensors right on them works as lidar and they keep on mapping the area so that you can map more area. So when we talk about this from left to right, you are increasing the speed of your capture, but you are decreasing the accuracy. So where in terrestrial laser scanners, you can go up to 1 millimeter accurate, whereas in drone solutions, you can go up to a centimeter accurate. So the movement from in accuracy is starting from 1 millimeter to 1 centimeter or 2 centimeters, whereas the capacity is in an hour for a terrestrial laser scanner. If you can scan an area which is almost 200 by 300 meters, with a drone in the same time you can capture up to, we can say, a kilometer by kilometer area. So you will have at least 20 times more productivity, but at the cost of your accuracy. So based on the projects which we are running on, like for golf course, for townships, for whole cities, we can go for analysis with the drones to capture the reality and create 3D of everything. Whereas when we want a pre-season construction where we don't want to prepare parks, golf course, or any other mega projects, but we are looking more about a specific building construction, in that case we can use the laser scanners. And the good part is the data from all these sensors can club together in a single software, so that you can have a complete analysis of the building more accurately, as well as you can map the surrounding areas as well for the future requirements and meeting them. When a laser scanner captures, it allows you to capture the points like this. So these are the small dots which you can see on the screen. These all are laser scanners where a laser dot is striking on the ground and coming back to the laser. In the center, there are image which is captured by the laser scanner. So when you put your laser scanner and start capturing the reality, first round is it goes for scanning and takes all these points. Second time it takes the photographs, those looks like this. And then you have additional sensors like pollution sensors, temperature sensors, humidity sensors. So all those sensors also can be attached over the area, and then these areas will get a different information. So in that case, the sensor information will be provided by the secondary sensors. And what the software does is the software merges the data together. So if you see in this imagery, in over this imagery in the center, it puts all those laser dots. So now you can see the image as well as the point cloud together. And the good part is now you can even do measurements from these images. So it allows you to have, just imagine like a photo which is on your mobile phone. You keep on capturing photos. Just imagine if that photo is there and you can even measure in that with the accuracy of millimeter precision. That is called reality capture, where we are capturing what is on the ground in the real dimensions. You can see this image in front of you. So when we see and we look like this is a plant image which is captured with a 3D laser scanner. This looks like an image on the screen, but when you keep on zooming in, it is not the image, but these are very small laser points. Those are struck on this particular surface and returned back to the laser scanner, and then they have made everything look like an image. But in real sense, they are three-dimensional measurements where you can actually have all those things. So if you have any questions, you can just please put your question here so far in case of reality capture, so that we can move forward to the next section. Now
Doctor, we decided to do the questions at the end, if you don't mind,
Okay.
so that we don't
No
interrupt
problem.
your flow of talking. And then at the end, Professor Mohannad will be saying all the questions.
No problem. So I'll go
Thank
ahead.
you.
Okay, so how it becomes a solution. Because laser scanners are okay, this is a device, this is a hardware where you put, and in this presentation we'll discuss about this hardware in the coming few slides, that how it works. So laser scanner is not only good enough for reality capture. What we need, because we want to save lots of money in terms of delivering things on time, speeding up our construction process and delivering the quality so that the walls are perfectly vertical, the floors are perfectly flat, and all the complete structures, those are as per the BIM models or the Revit models, AutoCAD models we have designed. And to make this, we have to make two things together. One, a hardware which can capture the reality, and another part is the software part, which can read from the data which is captured from the scanner, as well as which can club your Revit and AutoCAD designs together with the 3D model and tell us the comparison, give us the construction monitoring, give us the flows those are happening right at the step when we go wrong on the construction phase. And for this, we use first the scanning, and then later on we'll go for the software. So when we talk about laser scanner, this is an example of the first laser scanner. So laser scanners came in market in sometime 1999. 1998, Cyrex has prepared first of its scanner, and then this is how the scanner was looking like. Today, when you talk about scanners, we will have even 1 kilogram scanner which can come in your cargo pocket and you can move around and you can capture everything. But this is how the scanner used to look like when we go in 20 years back. So this was the first series of scanners where you have to carry a lots of setup together to have positioning. Then you have to carry a theodolite so that you can give directions and have a reference points along with a big battery and all that stuff. And slowly the evolution started, and today's time has come where you can actually scan everything with RTC series of scanners. This is the most advanced series, I should say. Now in 2018, it got launched. So the scanners, if you imagine, this big scanner was capturing only 10,000 points per second, whereas this new RTC 360 has reached to a level where we can capture 2 million measurements per second. So the evolution talks about 100 kgs equipment coming down to 1 kg equipment, coming from 10,000 points to 2 million points together. And now at the easiest devices like our iPhones, our iPads, even the Android phones, we can visualize and control these scanners, and we can see in real time what our scanners are capturing, how the data looks like. We can add notes to them. So all these features have now started getting into this. For terrestrial laser scanners, when we talk about today's thing, we can choose between multiple devices, but there are 3 different kinds of scanners. Those are very much in the requirement of our construction industry. So one is, starting from your extreme left hand side, you will see BLK 360. It's world's smallest laser scanner, which is 1 kg in the weight, and it is size of exactly, the dimensions are around iPhone 8 Plus or iPhone XS Max. This is the size of a comparative, or we can say around a coffee mug size, which can capture up to 60 meters of distance, which has a thermal sensor as well as the lidar. So this is a device which is a multi-sensor device which has thermal as well as lidar and a photographic sensor together. So all together it works, but with a range of 60 meters and an accuracy of around 4 millimeters. The second scanners, those are the favorite scanners for the construction people around, for architecture and everything, is RTC scanners. Those are around 5.5 kg in weight, so easy to carry, yet most robust, gives you around 5K resolution. So it's like 12 megapixel image capture from 3 camera system, and in total you get a 432 megapixel image. You'll have 2 million points per second, and it will give you a live update on how the data is getting captured. And when you move the scanner from one to different position, it talks about that. And then we have P series scanners. This is called the most accurate scanners in the world. So these scanners can go up to a resolution of 0.8 millimeters. So you can imagine, if you have even a deviation in your building structure or your glass facade by just 1 millimeter, you can find that error. And then you can fix it before it goes wrong. Because if you are constructing a 100 meter or 500 meters heighted building, In that case, if the 1 mm error gets started at first floor, this will be few centimeters by the time you'll reach to 500 meters. So to understand all those smaller errors, those can be big disasters when the whole building is ready. So for all those mega projects, for road constructions, for bridge and all other different kind of structures, those require very high precision. Specifically like Museum of Future, which you can see on the Sheikh Zayed Road or Burj Khalifa. So all those kind of structures, when you have precision at most required, in all those cases, these pre-series scanners come in picture, and they have one more feature that you can upgrade them as per your requirement. So today I have a requirement of 120 meters project. I can go with P30. Tomorrow you want to feel like, no, now I got a bigger project of land preparation or a metro station preparation where the dimensions are big. You can go for upgrading the same scanner to a P40 series where it can capture up to 270 meter radius. And in tomorrow you get a project in Hatta Dam or somewhere where you want to construct a dam or you want to have a bigger area surveillance. In that case, you can upgrade the same scanner to P50 and you can capture up to 1 kilometer range. This 1 kilometer range is basically a radial range. So in real terms, you will capture a 2 kilometers diameter. These are different kind of scanners. And when we talk about three scanners, why we need to have three different kind of scanners? Can't we do everything with one scanner? Because this is the most common thing, that I'll buy one scanner and I'll use it for all the requirements. But no, we cannot do, because every job is different. There are few places where we have space constraint. There are few places where we have open areas. There are few very narrow tight spaces in a construction or in a plant area where we want to go for refurbishment. So in all the structures based on the environments, like in heritage, we need a different scanner, because the articles, the wall paintings, those are on the walls, are sensitive. We cannot throw a high energy laser just to capture those dimensions, because that will impact the heritage site, that might impact the paint, that might impact the old structures. Whereas there will be few places where we have very high and very sensitive areas, like high-rise chimneys, where we cannot jump on and then do the measurement. So we need a long range scanner. So depending on the requirements, how the structure is, we have different scanners that can be used. So suppose for your example, if we see on your left hand side, this is a site where the construction is happening and they are pouring the concrete. So for this thing, when you are going for concrete pouring, you can always go with a 2 to 3 millimeter accurate scanner. You need not to be 1 millimeter or sub millimeter accurate for this job. Whereas when you are going for cutting and fixing on the second stage, on the second image, if you see from the left, the bridge construction, you might need a little more accurate device with 1.2 to 2 millimeters of accuracy. Whereas when we talk about crime scenes, you need to have sub millimeter level accuracy, because there are buildings, those collapse because of the architectural issues. And then we need to do an investigation where we have to monitor the structures, where we have to understand the changes happen due to the seismic activities. And now when we talk about another example, which is good, every must have heard about the Lebanon blast. It's not only the building which has blast. Because of the shock wave, all the nearby buildings in few kilometers range have an impact. Whether these buildings are straight at 90-degree or these buildings have a minor change. They might have a inward movement, they might have a outward movement, and buildings might not collapse today, but they might collapse after a year, because they have a different change in the structure. So to know all those minor changes, our scanners has to be more accurate. And for those kind of jobs, we need very high precision scanners. So depending on the customer requirement as well as the project what you are delivering, you can choose your scanner which is good for you. So we'll talk about a few details on these scanners now. The scanner which is in front of you now on your screen is like a P series scanner, which can capture up to 1 kilometer of range, which has a full onboard HDR imagery, so that you don't have to worry about the exposure levels, and you can work on day night. It can do the fastest scan in 20 seconds in case of road structures, in case of very crowded areas where you want to have critical infrastructure monitoring, you can do 20 seconds. These scanners are weatherproof scanners. So the good part is, even it is raining, it's heat of Middle East might be 60 degrees, 65 degrees, or it can be raining at any point of time in any other part of the world, or it is you are working on a project which is very close to the beach, or it is offshore construction or offshore monitoring of the plants where you have everything humid. So these scanners are designed in a way that they are weatherproof and they can work on any of the environments in open door without having any protective covering. So you don't have to worry about these devices. Just put your device and let it run, be it heat, be it rain, be it any other kind of harsh environment or dust particles. These scanners can do it and deliver you the best quality data. The second ones are RTC scanners. Those are the world's fastest scanners, can capture up to 2 million points, can take the whole scan and the image under 1 minute 26 seconds. They have HDR imagery with 432 megapixel images. They have in-field registration, weighs around 5.5 kg, and the range is 130 meters in the radius. So you cover 260 meter in diameter area for capturing this. Completely designed with anodized aluminum casing so that you are always free from all the magnetic interferences. And the good feature is we cannot make our construction sites clear always. Labor will be working there, vehicles will be moving around the area, and for that these devices come with a sensor and a double scan feature where the scanner will automatically take care of the moving objects and it will remove all those things. So for example, if I take you in a real sense, when you capture a photo of your friend standing somewhere in front of you, or you are capturing a building image and some vehicle or some person passes next to it at the right time when you are actually clicking on the shutter, and you find this person in the images, now you cannot use this image for any other purpose. You have to just delete it. So for all those kind of situations, now RTC 360 allows you to take your measurements of the buildings and capture them in a double scan mode where you can remove all the moving objects, all the moving labor and all construction workers around the area, and you don't have their images around the scene. The smallest scanner which I discussed was BLK 360. So this is how it looks like, and it can be operated using your mobile phone, iPad, or you can use it with the Android phone. It gives you HDR and thermal images. It weighs around 1 kg, has a range of 60 meters. And for this thing, this is the best choice for a beginner or for a learner, because you just have to press this one button which is on the screen, and you don't have to know about how the scanner works, how it will gonna take the pictures, how it is gonna take the measurements. Just go put your scanner and press this button, and this will automatically capture everything all together. And then once you have everything together, then we will take this data back to our computer so that we can process this data in the computer in the software. So after these hardwares which you have seen, BLK series, RTC series, and the P series data which you have captured in the field, you bring that to the laptop. So now we will go for the desktop softwares, how it works. So all the data captured from any of the sensor, it can be BLK, it can be RTC or P series, comes to a software called Cyclone. Cyclone is a 2 decade or more than 2 decade old software which is in use with our solution starting from the first series of the scanners, and still it stands the most robust model, where we have Cyclone has multiple sensors. Now you can choose between your requirements, like you can have Cyclone normal register, you can have Cyclone survey for your survey requirements, you can have Cyclone model for your modeling requirements. So like that, now you can have all those different kind of requirements where you can use the Cyclone different variants. When you use a scanner, what we do is we put one scan on a place to capture, and then we have to put it on a second place so that we can have the second image, because the whole building cannot be captured in one image. Suppose you have a big floor or you have to capture a building around the area. What we do is we put scanner at various positions, and then we try to merge the data. This is like Google Street View. So when you make your Google Street View, you have to jump from one place to another place to actually again rotate and see this. The same thing applies when you have a home where you have 5 rooms or 6 rooms or 2 rooms. When we want to make a complete virtual 3D of that room, we have to go into every room and take one image. Same way, when you want to measure the buildings and have the full structure all around, you need to have all those structures together. And in that, what we do is we take multiple scans around the area with some common areas so that we can understand the dimensions. And the software, which is Cyclone, allows us to create the connection between all these three scans together, 5, 10, 100, or even 2000, 5000 scans. So the buildings, those are hundreds of floors and having more than 80, 90, or 100 rooms each floor. To collectively together make that whole building plan in a single stage, we need to have Cyclone software, which allows you to register the data. So this allows you to register the data, which you can see on your left hand side. It merges the data from different scan positions, from different scanner sensors. It can be of any other brand as well as from Leica. So this software is strong enough to handle data from all different brands those are existing around us. Post that, it allows us to have a digitalization of this data, which allows us to open the same data in Revit, in AutoCAD, in Navisworks, in BricsCAD, in SolidWorks, or for plants, it can go to PDMS and 3D Reshaper for further analysis on cut and fill calculations, query analysis, volumetric calculations, and your Revit analysis as well. So it allows you to digitalize those buildings right in your existing platforms. And post that, it also allows us to create a virtually visualizable area where it allows us to have a very easy format which is available with us, and we can use this platform for doing the analysis, and we can calculate all the differences. We can share with the people sitting on different parts of the world, and we can have all those analysis together, and they can read out the areas, they can see the information and change it. So this is how it works: is you are working on a site, you do the scan, you register the data, and then you create a true view. Now somebody sitting in different part of the world can actually go and see all this area. They can visualize the area, they can note down, they can move around the scene, they can take measurements, they can take temperatures. So all those things can be done using this. So it virtually brings that whole building right to you on your desktop, and now you can do any analysis. You can highlight those features as well. So if you have a issue that you have a MEP pipeline plan, which is here, and this MEP pipeline doesn't meet the construction requirement, there is a pillar which will collapse. So in all those cases where there will be clashes, there will be anti-clashes, there will be missing components, all those things can be highlighted right here, and then you can have analysis on those parts. This image, can you see it around? So it's multi-modalities, those are running around. We have buildings, we have transport, we have trains all together, and we all grow together. And in cases when we have to have a full smart city, which is the concept now, and I'm very much sure you all being new engineers and the experts of the field, the pressure is to have connected buildings, have connected structures, have connected infrastructure. And to meet all these things, we have to capture the larger areas. And for capturing those larger areas, these terrestrial laser scanners are not enough. Because you can measure a building by a terrestrial laser scanner, but the moment it comes to capture the whole city, to capture the roads, to capture the areas around the buildings, in that case, what we need is we have to capture larger environments. Suppose just imagine like you are staying in Dubai or you are staying in Abu Dhabi. You have to capture all the roads, all the streets, everything. It will be a year-long, or I can say 2-3 year-long project where you can map everything. But we don't have that much time, because every year, if we take 1 year to just map a city, then definitely by the time there are new buildings, those are coming up, and we will never be updated. So to meet all those requirements now, we have today's mobile mapping systems. So those are like can be mounted on the backpack, so a person can have it in his back and he can move around the city. There are mobile mapping solutions, those can be mounted for the suburban and rural environments with GPR solutions. or we can have vehicle mounted solutions and human pushed trolley bed systems where we can just push the scanners and calculate the data. So these devices, those are like mobile mappers, have enabled us to capture more areas. And the scanner which you are now seeing on your screen is like a Pegasus 2 Ultimate. This scanning system has a capacity that it can capture up to 100 kilometers per hour. So it depends how you drive the vehicle. So once a device is mounted on your car, it can be any car. It's independent of everything, has a satellite GPS solution system mounted on the device, as well as a point cloud capturing rotor hood, which can go up to 1 million points per second, and have multi-sensor cameras. Those are capturing 360 images all time, with a inertial momentum unit, which allows the device to understand its orientation, its movements, right and left tilts, and the calibration things, so that you just drive your vehicle and the device keeps on capturing around your roads. And this has a maximum range up to 120 meters on the sides of the road, so that you can capture anything or by a single flight. So you can just move on the road and everything around the road is captured without any worry, and you can capture most of the data with more accuracy. Once you have captured this data, it allows you to have various analysis. Before you want to construct a new road, you can have a land analysis. Once you have a constructed road, you can have repair analysis. You can do a classification for the lane lines, clearances, barriers, digital terrain modelings, digital surface modelings, and even the overhead wires, if in case you have wires or any other construction material, or we can say the sensor lines for CCTVs, for electricity, those are running around the area, so that you can have better clearance analysis in construction of the roadways. So all these things allow you, but these vehicle based devices cannot go everywhere. When we talk about a car based model, I can go only on roads. But since all the cities have a old heritage history, so be the city is of Dubai, where we have Bar Dubai, or be the city somewhere in Iraq or in Mecca or in Riyadh or anywhere in the world, be it Paris or Rome, we have our history with us. We have thousands of years of history where streets were not wide. We have narrow spaces, we have buildings, we have forts, we have uneven surfaces. And in all those cases, when we don't have a vehicle access, we can use mobile mapping solutions like this, where we can mount it on our back. It'll be around 10 kg to 12 kg in the weight, including the batteries, it comes 12 kg, along with the additional tablet, where you can have a GNSS, which is industry grade GPS rover, have imagery as well as the point cloud data, and we can map the same way what we were doing with the terrestrial laser scanner by mobile mapping solution, and we can capture the whole streets. Once we have captured all these data from different solutions, we can merge this all together. And now I would like to discuss few of the case studies. So this is case studies coming directly from Dubai. I'm very much sure you all have seen Museum of Future at different construction stages. But do you know how it get constructed? All these pipe pillars where you see the construction assemblies, none of them was designed here in Dubai. They all were getting done out of the main city in Dubai. So the fabrication of all these components was happening outside. It was not here in the main city in near the Sheikh Zayed Road, because the space constraint was there and we didn't have that much open space here. So in all these cases, when we were having this construction, we have to make these fabrications out of the place, and we have to carry those, we have to transport these all pillars right back to the place where they have to be assembled. And imagine if just 1 degree angle is having a deviation, or have 1 millimeter error on all these pillars, and one of the nut is not meeting the requirement, this building will never be this marvelous structure. So to meet all these things, the project was given to BAM Constructions. So BAM is a contractor for that particular model, and they have one Revit model which was available with them. And the building has to be monitored on each and every stage, so that they always deliver a right thing on the construction. And how it was done was, they have used a P series laser scanner. So you see these green lines here on the side is basically a laser scan and the structure. So they have merged the data together so that they can clearly see that what they are going to attach here will look like, and it will meet the Revit model. So you can see the Revit model design here, as well as the actual structure and the laser scans together, so that the all three things together are verified, and they see each and every angle and every part of this building is accurate on the place, no angle deviations, no dimension deviations, and together we have made that. So all these things have helped the construction agencies to work in simultaneously together along with different vendors, where one is constructing, one is fabricating, another is doing MEP work in the same building, so that they all can have everything together. Another thing which we can see is an example from ancient city of Petra, which is more of architectural side. So to learn all this structure, we don't have 2D or 3D sketches of them, and we want to renovate them. We want to do further analysis. We want to understand the architectural understanding of these buildings, and in all those terms we want to have 2D and 3D designs. So this old Petra was scanned by a scanner called RTC 360, and then it was digitalized from a real structure to a digital structure, and then post that this digital structure was analyzed on how it looks like, what are the dimensions, all the structures inside and outside the building, when you look at the dimensions as well as how it looks on all 360, so that if you want to replicate a model of this, or you want to have the right dimensions for refabrication, you can get most accurate analysis, and even you can understand how narrow spaces are, how you can put on the buildings, how you can bring the machinery to work on these particular environments, what kind of damages will happen if you do something wrong. So in all those structures, and to restore our heritage, we have done using all these structures for RTC 360. Then the people those are staying in UAE must have visited Global Village. This is a place where you can see a harmony at an international level, where people from different countries all together work to and stay in different cultures. They show their cultural heritage, and in all those structures, when they were building this, a proper analysis of this was required, that how to enter, how to exit, what is the space maintenance, how these overhead lines can be managed, how the structures will look like. And this was done by a BLK 360 scanner, where the construction and the refabrication companies, those are making the structures, layout plans, virtual reality plans, they have used BLK 360 as one of the sensors for their jobs, and they have done this whole analysis where they have used this scanner to understand the space as well as to do the changes. This is a video which shows about how the structure was measured, and then how it looks like in 3D, as well as how you can take those measurements. Those are required for inaccessible areas where you want to have dimension in terms of height, in terms of angles, in terms of space. So all those analysis was done using a scanner called BLK 360. Along with this, now it allows you to have the sensors. So in this case, now once you have captured the area, you can have tags, and these tags can also be visualized. Once you have this whole solution, then it comes like, I have a scanner, I have scanned everything, I have a software, I have processed everything and made everything available to me, but I am not yet getting how it saves my money. Because this is good that I know my structure, this is good that I have constructed, and I have made everything processed in the software. Now everything is available within me in 3D. But what do I do with this 3D? And in terms, it allows you to save your money on different aspects. So the first aspect is, if you look at plant process, when you want to go in plants, it allows you to take measurements of all the areas those were not accessible, where you don't want to jump on plant to plant and you want to do the measurements of platforms, risking yourself in the exposed environment, you can just stand at a very good distance, which is like 150 or 200 meters away from the actual structures, and you can just take their measurements based on the kind of structure or kind of plant it is. And later on, this can be utilized for your construction, for your monitoring, for plant refabrication or plant expansions. You can do your tank calibration. So if you have a deviation on your tanks yearly, when you have to calibrate your fuel tanks, your water tanks, your all the different kind of storage information, in that case you can do various analysis using the same point cloud data for the roundness, verticality. You can have 3D inspections, you can have differential settlements and localized settlements all together for the tanks. Same way, you can use the same data which is captured in 3D for your facility management by taggings, where you can do tags for the flammable areas, you can tag for the calibrations, you can tag for the repair and maintenance lines. So you can use it in facility management, even for building 3D geometrical modeling. So if you have a plant which is 100-year-old and now you don't have 2D or 3D model, you want to replace the pumps, you want to have additional tanks, or you want to completely move this industry and you want to have a different new plant on this particular place. So for all this information, you can scan the data and you can make completely 3D geometrical models for retrofit as well as renovation of piping factories and plants. This is an example where in the Cyclone software, it shows how you can actually quickly design the pipe. So if this is a pipe in a plant and you want to have a run pipe, in this case, you can just scan and say the software that do a fit plant. So automatically the software will find out the dimensions of the pipe and it will automatically find the space and do a modeling for you. So for when you want to model a old plant, you can just continue clicking at few places and the software will allow you to model the whole pipe of the plant. So in that case, you can have 3D models very quickly for the plant, where it always a tough task to go into plant and take the measurements and then do dimensions and all those aspects. In terms of construction side, when you have historical buildings, you can use this data to generate your DXF or DWG models for 2D and 3D CAD drawings, as well as it allows you to have scan to BIM data accuracy, where you have a Revit model which you can see on the gray, whereas the real ground is available here. So now you can merge your real world with your office world. So you have a model in Revit and you have the real ground. Now you can merge this all together and you can see if you construct this building on this particular open area, how it will look like, so that you can have a vis-a-vis analysis on how things will be on the real grounds rather than just making a Revit ground and understanding the area. So if you want to construct a building in the narrow spaces, you can actually see the analysis and see the building clearances, how the structure will look like, how much space clearances you have, how to monitor the progress. So all those things can be done using 3D scanners. In cases where we have old buildings and we don't know where the walls are, where the buildings are, in that case, we can use the same solutions for creating a as-built modeling for the base design in your AutoCAD and Revit models. This is an example which talks about you just have to keep on clicking and the software will automatically do all these line snipping so that you can make your draft models very quickly for the buildings. Post that, the biggest problem in construction is for verticality and flatness. So your walls has to be perfectly vertical and your floors has to be perfectly flat with the angle slope. And to meet all those requirements, the softwares and the data which we are capturing from laser scanners can be used for flatness analysis as well as verticality, and we can generate reports for FF and FL analysis. In cases when the construction is done, now the time is there where we want to audit the building. We want to verify that all the components of the building are in place. They are not missing. So in all the cases which we can to go for construction verification, where we can capture the building and put it on the building plans. And when we put all those things together, we are actually getting data where we can see where things are wrong and where things are right, whether there are components those are missing or whether the components those will be clashing. So in this design, if you see, the piping design says the pipe has to come like this, but in the real data the beam is construction here, and there, because of this pillar over here, a slab is touching this pipe. So this is an area where the clash will be. So it allows you to have early warning for the clash detection so that you can have workaround. In public safety for road accidents as well as for the building collapses, we can do the 3D data capture, and this data can allow us to do an investigation. It can be a building collapse analysis, or it can be used as a vehicle accident or any other road construction analysis as well. Last but not the least, we can use it for the mine work. So in areas where we want to construct new structures or we want to clear the land, we want to have cut and fill activities, we can have digital terrain models. For doing the analysis, we can do volume calculations for your query. So we can calculate how much material will be required for land and cut and fill situations, how much construction material will be required for a particular site, so that we can save on the right estimations and have better budgets for the buildings. For mega structures like metros, hyperloops, or all other structures where we have to work on mobility, as well as for high-end infrastructure, for very complex road structures where we want to do surveys or we want to understand the structures, which is not possible by normal photographs, as well as for surveys. So in all the complex environments, we can use mobile mapping infrastructures for doing all the complex structure 3D data, which you can see now on your screen, which shows you that how you can map the whole data, and you can save the cost in terms of doing the survey without closing the roads and without incurring the costs on related to the survey. Those will go month long. So you can do everything in an hour or an hour and a half's time, which a survey team will take around a month to capture the data. In case of our existing structures like heritage buildings, the construction bridges, or the buildings, those are very critical for our analysis and are under the threat zone of movement or having an impact of the environmental factors. There we can do a deviation reporting and have a repeated scans of today, after 6 months, after 12 months, and then we can compare that data with the BIM models and can understand if there is any movement on the buildings after a seismic activity. Year on year mapping, like after a 50 years old building, if it starts depletion, so in that case what are the changes. The cases like Lebanon explosion, in those cases how it has impacted all the nearby structures around the buildings. So we can do all this deviation analysis and reporting for the structures. Sometimes we don't want to know what is over the ground, but also what is below the ground, and we might have severe lines running across the city laid 100 years back. And in all those cases, the mobile mapping devices even allow us to map the structures those are below the ground and connecting them over the ground, so that we can understand that where exactly on and below the ground those assets are, those structures are, how we can repair them. We know the dimensions of these structures, so can we utilize them for further for sewage or any other kind of utilities. And we can use for crack analysis as well for road and runway surface damages. Once we have captured all the cities for overground, underground, with the GPR data, with terrestrial laser scanners or reality capture data, now we can connect all those buildings together. We can now make those buildings as smart buildings. Why? Because you know a building structure, and now with reality capture, you know the structure, you know the dimensions, you know the measurements of those buildings. And with that help of those things, if you want to put solar panels, you want to have grids over the buildings, you want to connect them with the connectivity in terms of space, in terms of routers. So when you have information about those whole cities, about the infrastructure as well as their total geometric positions, then we can have better connectivity. We can set up the networks, we can set up the boosts for the network boosting devices, we can have the connectivity of different kind of sensors together, and we can make those cities smart. We can do high definition city mapping for smart cities in an accurate way, so that we have up-to-date data of the construction. And
Doctor,
even
I'm
for
sorry,
Sorry,
I'm sorry,
just to let
doctor.
you
Yes.
know, Yeah, we are running out of time.
Yeah,
So
this is, I believe, the last two slides, and we will be
Okay,
getting
so
over. Yeah. And in some of the projects where we are running around the buildings, we have some mega projects. Those are having villas and establishments. So in all those areas, we can have ultra mobile mapping with a drone solution where we can just map all these areas. So this is in terms of all together total what we can do is, so we can do urban survey, we can do as built, we can do our tank calibrations, high definition surveys. So all the segments, those can help us out together with the data which we have captured with the sensors. And now I would like the professor to open this session for the questions.
thank you so much, Doctor, for the
yes,
interesting.
we wanted to have more time for questions, but because we're running out of time, so we will select some of the questions, not all of them. I'm sorry, Mohammed. I just have a quick question from my side before you start all the questions. For a campus like AUD, how long will it take for you to, for example, if you want to take all the buildings, how long will it take for this to happen, time-wise?
Okay, so this time depends. If you want to have the outside structure, then probably in 2 hours of drone flight, you can capture everything from outside.
Okay.
But when we want to go inside the buildings, like we want to understand all the buildings and all those things, so it depends on the room to room and how accurate data we need. So probably with the RTC scanner, it can be around a month or 2 months project, but with the BLK to go kind of device, you can do everything in like 2 weeks time.
And it will, if you have people inside walking, it will not affect, correct? As you were explaining.
No, it will,
okay.
it will not. It will not
no, but if I'm talking about just the outside shell with the location of their building, with the trees and whatever is happening on campus, this will take less than a day?
Yeah, it will take less than a day.
Oh, wow, that's impressive. So then we can have the 3D element that we could move to Revit, we could move and transform it into a digital, you can move it to the VR if you want, and you could have, an experience and all of that?
Right.
Okay, interesting. Okay, that's good to know for time-wise, because then it's not very complicated.
No, it's not very complicated.
The resolution of that, because I saw some of the images, the resolution were pixelated and more and less real. When you scan, will it become a photorealistic scan or no?
Okay, so the images where you see the resolution, those are not images.
Okay.
These are the laser scans.
Okay.
So these are the laser dots. For images, you will get a real-time images. Those are like the captured from your camera.
Perfect. I'm done with my questions.
Just just Doctor, one more question. Why the accuracy is different between the laser scanner and the and drones?
Okay, so the thing is that there are multi factors. Like when you have a terrestrial laser scanner, you put it on a ground and it doesn't move. So only the error is of what the laser is, like laser goes, strikes to a surface and comes back. So it is basically one fixed point and a stationary point from where you take the measurements. While when we go for mobile mapping devices, in that case, your drone is also flying. So the drone has a movement and the laser has a movement. So it adds two things together into that. So the movement of the device gets multiplied along with the factor, because both things are in the movement.
All right. I think that's, yeah.
Mohammed, I have one more question, if possible, for the doctor. Let's say for existing buildings, and when you scan them inside, let's say, like what you said, maybe very fragile building and so forth. So let's say an old building and you want to scan and you don't have a plan for it usually. And the old buildings also have structures, have pipes and everything in the wall. So when you scan this, you get all these hidden information that are within the walls, within the ceiling and all of that, or no?
No. So there's a device called see-through that works together with the scanner. So what generally do, it's a combination of multi-sensors. So what you get is you get your building information with the laser scanner.
Okay.
Because it cannot penetrate, but then we do it with GPRs, ground penetrating radars, if we have utilities below the ground, or inside the walls if you have, then we use a device called see-through. So that can see through the concrete up to 80 millimeters. So that device has a capacity that if you have a pillar, it can even tell you how many rebars are there inside that pillar.
Okay, so there is a special technology that will allow you to access all of these.
Yeah, and that is available with Leica. So we have the holistic
it's not
solution.
incorporated in the same scanner.
No, it's not there because scanners are line of sight scanners. So they see, they just throw and see what they can see is by the human eyes what we can see.
Okay, got it. Thank you.
All right, thank you so much, Doctor. Thank you so much who joined us today, and thank you, Dr. George, for organizing this. That was the last webinar for this semester, fall 2020. So hopefully we'll see you in the next webinars for next semester. So thank you so much for all of you, and have a good day. See you.
Thank you.
Thank you. Have a nice day.